I have them. I saved them for you.
Okay, it's with you.
Mm-hmm.
Thank you
Your
so much.
notebook.
Yeah,
Hey, Deborah.
Hi, Miss Samantha. How are you?
Hi,
I'm good.
Deborah.
Hey, Miss Denise. How are you? Thanks for your help yesterday.
Of course.
Hello.
Yeah,
We always love having you.
I feel so good now. I've been doing maths all day.
And the exciting news is the lesson we're looking at today, remember, is the last lesson we have. So we're going to be putting together everything we've been doing with inequalities with two variables to help us solve problems. So it'll be building on what we've been doing, especially in these last two lessons.
Okay.
So we'll go ahead and we'll jump right in. There's going to be three different situations that we look at in this section here. And for each of these situations, we're going to be doing four things. We're going to write an inequality to describe the constraints and specify which each variable represents. That ability to represent like a situation with an equation or an inequality is a theme that we've been working on throughout this unit. So this will be a good way for us to practice that. The second part is graphing each inequality. We had been working on graphing the inequalities, especially yesterday. So we're going to be adding on to that skill. And it's going to have us sketch the solution region on the coordinate plane right here and label these axes. The third thing we're going to do is we're going to name one solution to the inequality and explain what it represents in that situation. When it comes to solutions and solutions for inequalities, we've seen that inequalities have a lot of solutions. We're just going to be naming one. And then part D, there's going to be some question related to the situation that we're going to answer. So starting with this first one here, we've got a customer opens a checking account and a savings account at a bank. They will deposit a maximum of $600, some in each of those accounts. So they're depositing a maximum of $600, some in the checking account and some in the savings account. And it tells us they might not deposit all of it and they might keep some of the money as cash. They're depositing a maximum of $600. I'm going to have you both take a moment and see if you can do this first part. See if you can write an inequality to represent the situation here. Take about 30 seconds to do that. Remember, whatever variable you use, you want to tell me what it represents.
That would be C plus X equals 600, where C is a checking account and S is a saving account.
Equals 600, was that right?
Yes, correct.
And then you said C is the checking.
Account and S is the savings.
And S is the savings. Okay. Mojira, do you agree, disagree? Is there something you want to change or add?
yeah. She's right. I just put X is a checking account, Y is savings account. So
Use
the
different variables.
constraint is 600. So that's it. She's right.
I might, if it's okay, Deborah, I might change these to X and Y just to help us when it comes to graphing.
That's true, yeah.
There is absolutely nothing wrong with using your own variables, but I do think it'll help us a little bit more when we get over to that graph.
Okay.
I'm going to underline one word here. Why do you think I'm underlining that word?
Because of the equal to.
Equal to, yes.
Yeah. If we want to write an inequality, you pointed out that equal to sign. What should we change that to if we want an inequality?
Less than or equal to.
Or equals to.
Less than or equal to.
Where are you getting that from?
Because they said the maximum they have to have must be
600.
Mm-hmm.
So it can be less than 600, but it must not be more than 600. So that's why it's less than or equal to 600.
600.
I love how you reworded it. That maximum of 600 means they could deposit less than 600 between the two accounts. They could deposit exactly 600 between the two accounts, but not more than 600. So we end up getting our inequality x plus y, where x we said is checkings. I might change it to like a money deposited in checking. So we got the money deposited in our checking account plus the money deposited in our savings account needs to be less than or equal to that $600. I heard you pull out that $600 there is a constraint in this situation. So we've got our inequality here. The next step to this is we are going to graph this inequality over here on this coordinate plane. And it said earlier, we want to make sure we label our x and our y axis. Because you've already done a great job defining our variables, we can go ahead and use those definitions to help us label our x and y axis. I could label this x-axis right here is, yeah, and I'll say the amount deposited in the checking account. And then for our y-axis, it'll be similar. It's the amount deposited in savings. And I think I'm going to erase these just to give us a little room. When it comes to graphing this inequality, we always start by graphing the line of the equation. So I want to start by graphing the equation x plus y equals 600. In order to graph that equation, what could we do to help us graph it?
Find the y-intercept. Make x intercept 0 from the origin, then find the y-intercept, which we can pick 300.
So I heard make that x 0 to help us find that y-intercept. Yes. If I make x 0, this equation is real easy to do in your head. If I make x 0, what must y equal?
Y must equal to 600.
Yeah. So we've got that y-intercept is at 600. Let's go ahead and mark that on our graph here. What that's saying, by the way, if x is 0, remember you said x is the amount deposited in checkings. It's saying if this person deposits $0 in their checking account, they can deposit $600 in their savings account. Yeah. To show that on this graph right now, the graph isn't numbered at all. You could number this different ways. I think the way I'm going to do it is I'm going to make every other line 100. So I'll make that 100, 200, 300. You want to find like the happy balance between not making it too squished, but also making sure you give yourself enough room to put that number. So I went ahead, I counted every other line by 100, and I want to mark that that y-intercept is right here at 600. Now that's just a single point. I need to graph a line. So you found our y-intercept is 600. What else can I do to find another point on this line?
Now that we know, so we can choose 300 and 300.
Oh, okay. So you know another point is going to be at 300, 300?
That's the middle point, the intercept. So that's where the intercept. So when the checking is saving, I mean it's 300, the savings is also 300.
Okay. So I'm hearing a couple things. I'm hearing if x is 300, then y is 300. So you're finding another point on the line. If I were to plot that point, that's 300, 300, that's right here. That's not an intercept. This first point here at 600, that's an intercept, meaning it's where the line crosses the y-axis. Okay. It's where it intersects the y-axis. Okay. This is another point on the line, which is good because now I can see where that line is. I can see it's going through these 2 points here. If I wanted to find another intercept, I would want to find where the line is crossing our x-axis.
Make y 0 and make x 600.
Yeah, if I make y equals 0,
and then make x,
and we get, yep. So I get that other point is here. Notice you only need 2 points to get that line.
Yeah.
So you could do it either way. Either way, it's giving us this orange line right here. So we get that orange line is the graph of the equation x plus y equals 600. Remember, we're not graphing an equation, though. I'm graphing an inequality. I'm trying to graph this inequality right here. So I need to make some changes. If I'm trying to graph x plus y is less than or equal to 600, there was two things we had to decide on. Do you remember what those two things were from yesterday?
Which part is the solution to be shaded? Is that correct? Okay.
Yep. So we've got to figure out which side of this line has the solutions. Is it the area below the line or the area above the line? What do we think?
Area below the line.
I hear you both saying below the line. Why?
Yeah.
Why would it be below?
Because
go ahead.
The equation says less than or equal to. So any point below the line will give us that solution. But if we pick any point above the line, then it's going to be greater than the 600, the constraint that we have.
Yeah. And so what you're describing, we had talked about like test points. So I heard you say if we pick any point above the line, it's not true. It's not a solution because it would be above a 600. Let's pick a point as an example. I'm going to pick this point right here. That's at 500. It's at 500 for both of them.
Yeah.
If she deposited $500 in her savings account and $500 in the checking account, is that meeting that constraint of a maximum of $600?
She's richer. No, but it doesn't mean
it might be desirable, but it's not meeting that constraint, which is what we mean when we say it's not a solution. If I picked any point in that shaded area you told me about, so for example, 100, 100, is that point there meeting the constraint of a maximum of $600?
Yes.
Yeah. As would any other point in the shaded area here. Now, there's one other thing we had to decide. We've picked the shading. The shading is if you're looking at points below the line and points above the line. What about points on the line itself? Earlier, Deborah had mentioned this point right here at 300, 300. That point isn't below the line. It isn't above the line. That point is on the line. Are points on the line in this situation also solutions?
Yes.
Yes.
I hear you both saying yes. How do you know that?
Is equals to the constraint.
Yeah, let's pick a test point and then we'll see.
So what we picked that test point 300, 300. If I use that, we have 300 plus 300 is less than or equal
to
600.
Yes.
If you pick 400.
Is that true?
Yeah, that's true.
Yeah. So we're seeing that points on the line are also solution points. Points down here in the shaded area are solution points. Points on the line are solution points. Ooh. What would I need to do to my line to show that points on the line are solution points?
You need to use a solid line. Is that correct?
Yep. That solid line that we currently have graphed right now is a solid line. That's how we show that points on the line are a part of that solution point. It's like the line is shaded as well. What would my line look like if I wanted to show the point isn't a solution point?
A dotted line or a dashed line, whatever line.
Yeah, you could use one of those
line besides solid line.
Yeah. So if we had figured out that that point at 300, 300 was not a solution, that means I would have to change that line I just drew to a line that looked like this. That's not the case here, but it could be in a future problem. So I wanted to talk through it. You guys are doing awesome. I'm going to have us come down to, oops, hello, there we go. I'm going to come down to number 3, or I'm sorry, part C, not number 3. Part C says, what is one possible solution for this inequality? We've talked about a lot of different things here. I think you've already answered this question somewhere earlier in our conversation. What's one possible solution here?
We could also have 400, 200, or 200, 400, or 500, 100. So we have tons of
you named a lot.
Infinity.
There are infinitely many correct answers. Yeah. I just wrote down that first one. You said 400, 200. If I
450,
asked you
50. Well, 450, 450, 150.
450, 150,
Mm-hmm. Yep.
why is that point you gave me a solution point? How could you justify your answer?
It meets the constraint.
Tell me more.
The maximum it has to save is 600. So it could also be 200 100. So which is also under the constraint. It could also be 0 200. So whichever one. But as long as it's not above 600, so because the 600 is a constraint.
Yeah. So you're coming back to that story and talking about the maximum here is $600. That's one way you could justify it. Is that the total of these two numbers, if I were to add them together, it never exceeds $600. I also heard in there you mentioned about how it's in that shaded area here. You could justify your answer by telling me it's a solution point, because if I find that point on the graph, it's going to be in that shaded area. And that shaded area is showing these are all solutions. Either of those are good answers. You could even come back to this inequality and say, if I substitute those numbers into the inequality, it gives me something that's true, like we did right there. A lot of different ways you could justify your answer. There's one last question, and here they're asking us to use all the stuff you've talked through, use this graph we created to help us answer this final question here. This last one says, if the customer deposits $200 in their checking account, what can you say about the amount they deposited in their savings account?
So it's going to be 200 plus y
Ooh,
equals 600. Or we do it this way.
200
Plus y is equal to 600.
Minus 200.
Or,
Yeah, you're right, Mugiraro. Keep going.
or we say 200 plus y is less than or equals to 600.
What you did, what you were doing before is right, Mujirayo. You just didn't complete it.
No, I use those two options.
Okay.
That is another option. The first option is 200 plus y equals 600. In as much as we can have anything, any amount below the constraint, it can be less than 600. So it can be 200 plus 100, as you rightly said here. It can be 200 plus 300. So it's going to be 200 plus y less or equals to 600. That is another option. The first one is 200 plus y equals to 600. So I'm using those two.
Yeah. And we had talked about when you're solving inequalities, you can use that related equation, which is what I'm hearing you say. I want us to describe what type of numbers can y be. And Deborah, I think you started solving it. I heard you say something about, what did you say?
I said you just look for you just solve for y. And in solving for y, you just subtract 200 on both sides. And then that gives you y equals to 400.
100.
So if it has so what you just do, you substitute the value every point in time. So we are giving 200, but we are not given the value of y, and to get the value of y, we just solve it out. So that means if it has 200 in the checkings, then the savings will be 400.
400, yes.
Equal to 400?
$400.
So if we know he deposited $400 in his checkings account, how much money is in the savings account? How much money could he deposit in the savings account? We've said he could deposit $400. Is that the only option?
No, 200 in the checking, then it will be 400 in the savings.
So if there's $200 in the checking, is putting $400 in his savings account the only option he has?
No, that's not the only option.
What other options does he have?
You could put less than as long as it's below.
Yeah. So I'm going to change that then to show that to less than or equal to 400. So for that answer, what could you say about the money he deposits in his savings account? He could deposit
anything less than 400 into the savings. Less than or equal to 400 in the savings.
Yeah.
Sorry.
Yep. He could deposit $400 or anything less than that in his savings account. Nice. Questions on this first one here about checking account, savings account, money before we move on to that next one?
We are good. How about you, Mujiraya?
I agree.
You say what?
You're feeling good about that first one? Ready?
Yeah, I'm good.
Okay. So we'll come down here to number 2. Number 2 says 2 kinds of tickets to an outdoor concert were sold. There's lawn tickets and there's seat tickets. And they tell us that fewer than 400 tickets in total were sold. Notice the questions are real similar. We're going to write an inequality. We're going to graph the inequality. And then we're going to talk about what one possible solution for the inequality would be. Let's start off with, can I have you all write an inequality to represent this?
Yes. X plus Y is less than 400.
And X represents
the lawn tickets and Y represents seat tickets.
I'm going to push you. Can you make that more specific? What about the lawn tickets?
Total number of lawn tickets sold.
Yeah. Yep. So I'm just going to write. I was attempting to put a number sign. Number of lawn tickets
sold.
Oh, good.
We are writing in math.
I got really excited because this new computer, I can write with a pen on it. But I think I'm still I need more practice. Let me type this part then. So we said X is going to be the number.
Yeah.
The number of lawn tickets.
Lawn tickets.
I'm going to use LT for lawn tickets if that's okay.
Yeah.
And then Y we're going to say is
ST. Number of ST sold.
Seat tickets sold. Okay. Okay, so we've got this inequality here. Before we move on to the graph, I've got a question. Earlier, we were using the less than or equal to sign, but this time I only heard less than. You didn't tell me less than or equal to. What changed?
Because fewer than 400 tickets.
The ticket they sold is less than 400.
Less than.
It's not equal to 400.
There, that's what I was looking for. It can't equal to 400. It has to be fewer or less than 400, which is why that or equal to sign is missing. Let's move on to that next part, which is where we're going to graph this inequality. Talk me through what are the steps you would take to graph this.
Make X 0, put your Y-intercept as 400.
So make X 0, and when we make X 0, our Y-intercept is, 400. I missed it. 400. If I want to plot that on this graph, how would you go about doing that?
Look for 1, 2. So our X is the LT and the Y is the ST. So 1, 2, 3, 4. 400.
How do I know where 400 goes?
Why?
The Y side. That's the C.
Where do you want me to put that point?
Let's do it 50. Let's go 50. because we are going below 400 when we start plotting.
So have like this first line here be 50.
Yeah.
Uh-huh.
50,
So
100,
50.
yeah, multiples of 50. 100,
Okay.
150, yeah.
And I'm not going to write them all out. I'll save us
Yeah.
that time of watching me do that. But if we're doing that, so we got 50, 100, 150, 200,
Yeah.
300, 400 would be right,
Yeah, right there.
here. What about our x-intercept?
Make x-intercept also make y 0 and make x 400.
Mm-hmm.
Yeah.
Yep. So similarly, if we make
Yeah.
the y this time 0, that gives us x is 400. You want to count by the same thing?
Yeah, please. Because we are going
We'll go
lower than
100.
400, so that will give us. Good. Yeah.
300.
That's even easier.
Okay. There we go. So I've got those 2 points. Let's keep going. We want to graph that inequality. What will come next?
Then we'll say it's less than. We've got our.
So in that case, go ahead, Deborah.
So we have our intercept now. So what we just need is, let's plot it. So any point below that point, any point on that point is not our solution, because we said it's below. So any point below those points is our solution. So that's the part we
Any
should
point
below.
Any point below the line?
Yeah. But any point on the line is not our solution.
How did you figure that out?
Because any point on the line will give us 400.
Equals
So
to
I heard 2
400.
different things.
So we are going to use.
So what does that mean then?
It's not going to be a
It's
solid.
not going to be the solution.
It's going to be a dotted line, or any line beside solid. Yeah.
Okay, so let me change that then. Let me go back in and do our dotted line. So those thoughts were coming so quick between you two. Let me pause and just ask a couple questions real quick. So I heard we decided we were going to shade below the line. How did you make that decision?
Based on the question, we said our constraint is less than. So it has to be anything less than 400. So any point on the line will give us 400. Any point above the line will be more than 400. So that technically tells us that any point below will be less than the 400 that meets the constraint of the total.
Yeah. So give me an example then.
It can be 390. Even it can be 399.
It can be.
It can be 399.5.
X can be 100, Y can be 50, whatever. Yeah. Like Muji said, it can be 399, it can be 0. So, sorry, I call her Muji.
Yes, okay. Right. So I heard this is like a possible solution, 150. Moji, I heard you say 399. I did hear 399.5.
Yes.
Could you think about what the context is describing here? Could they add up to 399.5?
Yeah, we can even have up to 399.9, in as much as it's not up to 400. So anything that is equals to 400 is not the solution, because whatever we are having should be less than 400. And 399.9 is less than 400. So 399.5 is less than 400.
I agree with her.
And what you're saying is right. 399.5, 0.9, those are all less than 400. Think about the context. What are we talking about in this situation?
We are talking about the constraint and the inequality there, which is less than 400.
What does 400 represent?
It represents the total number of tickets sold. For both the long and the seat tickets. The total number of tickets sold in general.
So think about what you were just saying. 400 represents the total number of tickets sold. So you were saying earlier it could be 399.9.
Tickets sold. Total tickets sold.
Can you sell 399.9 tickets?
No.
No, we are talking of money here, so it can be 319. So we are talking of ticket now, not money. So it can be 399.9. So that is why you are the teacher. We are the students. We are
You can
learning
have
more.
100.
But you're bringing up a really great point, and I'm so glad you did. If I didn't give you this story here, if I just asked you to graph this inequality, what you're saying would be true, right? If your X and your Y added up to 399.9, that would be a solution. But because we have this extra information here about how we're talking about tickets,
Yes.
mathematically, if they added up to 399.9, that is less than 400. But based on this situation, we're realizing 399.9 tickets wouldn't make sense.
No.
No, I'm so glad we got to talk through that. Let's go on to that. There's one last part to this one. That last one says, if you know that exactly 100 lawn tickets were sold, what can you say about the number of seat tickets?
So
It could be 50. It could be, as long as it's under 400. I mean, as long as it's under 200, we can substitute the value and work it out like we did the other time.
Yeah, do you want to do that? Let's do that.
Yeah, X plus Y is less than 400. So we said the loan ticket is 100, which is our X. So if X is 100, that's 100 plus Y, less than 400. So minus 100 on both sides. So that gives us Y equals 300. No, Y equals, sorry, Y less than
Y
300.
is less than 300.
Y less than 300.
That happens a lot when we make the switch to inequalities. We're saying equal. Okay, so we get Y less than 300.
300, yeah. So, if Y is less than 300, so we could pick any point below 300. It could be 200, it could be 100, it could be 50.
Yep.
Yes.
So we know the number of seat tickets would have to be less than 300 tickets.
300, yes.
Yeah. Okay, we've got, I think, time for one last one of these, which I'm glad we're doing number 3. Number 3 is fun. So continuing talking about lawn tickets and seat tickets, we're now told that lawn tickets cost $30 each and seat tickets cost $50 each. The organizers want to make at least $14,000 from ticket sales.
Wow.
Again, we're going to start off, yes, concert venues are rich. We're going to start off by writing the inequality for the situation here. So given that information,
that's X
is going to
continue.
X is going to be 30X plus 50Y equals
less than or equal to
14,000.
Talk me through how we got that. Where did 30X come from?
So the 30X is let me see. It's going to be and yes, the 30X is each ticket is $30. So we are going to multiply 30 by the number of tickets, a lawn ticket sold. So plus each ticket for seat is $50. So we are going to multiply it by the number of seat tickets sold. So the constraint is going to be less or equals to $14,000.
So I heard we're using multiplication to figure out how much total money we made from the lawn tickets, how much total money we made from the seat tickets, And then when that all that money is added up together, we want it to be less than or equal to the $1,400.
Make at least. No. At least. So it could be more than $14,000. So it's going to be greater or equals to $14,000.
Greater than or equal to.
Yes, greater than or equals to $14,000.
But not less than 14,000.
Greater than or equals to 14,000.
So we went back and we changed it. We noticed that phrase "at least" can be tricky because least sounds like less, but at least means you want to make $14,000 or more.
Yeah.
Which is where that inequality right there is coming from. So we've got our 30x plus 50y is greater than or equal to 1,400. Are we happy with that inequality?
Yes.
Okay. So let's go on to that next part. If I want to graph this inequality, what steps would you want to take?
Yeah, as usual, make your x 0 and make your y 1,400 and 14,000.
Make our x 0
and make y 14,000.
If I make y 14,000, let's look at that. That's not giving me.
It's not. Sorry. I take that back.
No, we are going to divide both sides.
Divide 14,000 by 50.
By 50.
Yeah. There we go. I'm not replacing y with anything. I'm trying to figure out what y equals when x is 0. So
y will be 280. So that's 50 multiplied by 50. I mean by 280. Y is 280.
Yeah. There you go. So we get our y is 280.
Yeah.
We figured out that when x is 0, y must be 280.
80, yeah.
So that's giving us that y-intercept. When x is 0, y is 280. So coming over to this graph here, how do we want to number it? Our y-axis.
Let's do hundreds. It's going to take a long. Let's do a multiple of 200. Because since we have 280 or 250, we can do 200 or 250, whichever one.
What do you want me to make each line?
Let's make it 100.
100 will be too long.
We are going to 14,000.
Yeah, so let's do 200.
We are going to 14,000, so we can make it 200.
Count here, 200?
Yeah.
If I do that, it's going to give you a really big number up here. All I need to do is plot 280 on the y-axis.
Okay.
We can spread it out a little more. So it's not so cramped there. Come on, erase. Hello. There it goes. So I'm going to propose we can do the same way we've been counting for a lot of these. Let's make every line 50. So that means here that would be 100, 150. This would be 200. Here, 300. That'll still be, it's spaced out enough. So we're trying to put our y-intercept here at 280. That line's 250, so it's going to be somewhere right there. Does it make sense why I changed that and why we're not counting by 200?
Yeah.
What about another point on our line?
Get the x-axis, so that will be divided by 30. So that would be Oh, I'm coming. Sorry, I made a mistake.
That one is a decimal if you think you made a
Yeah,
mistake
it's a
because you got a
decimal.
decimal.
That's what I just figured out now. 13720 divided by 30. That would be 457.333333333. Four
Four.
457.333. We can say 33. So
Am I wrong? I got 467.
46. Oh,
Let me
let
check.
me do it again. That's 1400 divided by,
Divided by 30.
by 30. No,
Yeah. Would you
1400
write?
minus 280. 14,000 minus 280. That's
Oh
one.
wait, we're not subtracting 280.
No, I
Maybe.
substituted. Oh, you
Mhm.
divided right away. I worked it out in math. Sorry. Yeah.
So no,
You're
you're
right.
okay. Let me put it. I'll put it here. We've got
Yeah, it's
30x plus
466.
50 times 0 equals 1400.
So we have
Yeah. Yeah, it's
466.7.
466.7.
So let's go in and do that. I think we can probably count the same way then. Let's make every other line 100. So 100, 200. Oh no. 300. Where am I at? 400.
600.
And then 500. That last one, 600. And we said 400. What? Where are we putting it? 467?
We have
467.
467.
466. So that's close to 500. Yeah, that point is
Yeah.
still good.
Okay. So I've got 2 points here. Let me make them a little darker. I got this point right here on our y-axis, this point here on our x-axis. I'm trying to graph this inequality. What comes next?
Yeah, put your line there.
What type of
So
line?
put a solid line
Solid line.
and you shade the upper part.
Put a solid line and we shade the upper part.
Yeah.
How did you decide those two things?
We said at least, so any point on the line will give us the
Solution.
14,000, the solution, and also any point above the line
Above the line,
will give us
the
what we are.
solution
But any point below the
Mhm.
line will be less
is
than
not.
14,000. So
Yep. So I heard a lot of good stuff there. I heard any point on the line is going to equal out to exactly
The
14,000.
constraint.
Anything above the line, how much money would they make for any point above that line?
yeah,
It
that's
could be
about
16,000, it could be 20,000, 50,000,
Extra money,
100.
bonus money.
they could make a million. Now we're saying it.
Yeah.
So
But the
uncountable.
key part is they're making at least 14,000. So I
14,000.
heard they're meeting that constraint. Any point down here where we didn't shade,
Will be below the
what
constraint.
could we say about that? Mhm.
That would
It would
not
be
the-
below that.
That would be less than.
So it's less than the constraint. So it's not the solution.
Yeah. So it's helping us see if that's their goal. It's showing what combination of tickets, of seat tickets and lawn tickets they would need to sell to meet that goal. We can answer this last question real quick. So that part D says, if you know that exactly 200 seat tickets were sold, what could you say about the number of lawn tickets? You could do all the math, but now we've got this handy graph here. You could always use your graph to help you. If they sold 200 seat tickets, which
So
one
it's
is
going to be
these?
200 times 30.
Mhm.
That is 600. So
Check real quick. 200 seat tickets. Which one of these is our seats?
Why
X
is it seat ticket?
is
Why is it seat ticket?
Y, yes.
That's times 50.
times
So
50.
that would be 50 into 200. I mean,
100, 1000.
that would be 30
250.
x plus 50 into 200 equals 14,000. 30x plus 50 into that equals 14,000. 50 times 200.
30x plus
50
50.
times 200 gives us 10,000. So 10,000,
13,000.
that's 30x.
30x plus 200
So
times 50.
13,000, that's 4,000. So 30 divided by 4,000. Sorry, 4,000 divided by 30. That's 133.3 something or something. Yeah. 133.
Yep, I heard it.
Yeah.
1, 3,
30.
3 point something.
Yeah. So x is greater than or equal to
4,000.
133.3.
So
Mhm.
30.
Now, keep in mind again what we're talking about here. We're talking about the number of tickets.
Oh.
4,000.
That's not the
Would we
one.
need to say how many lawn tickets would they need to sell?
We can just use a 133. So we take off the decimal. Is that correct?
Think about what this is saying. It's saying X, the number of lawn tickets, needs to be greater than or equal to 133.3.
So we can make it
Yeah,
134. We can make it 135.
round it up.
Yep, 134 or up.
Yeah.
And if you look at your graph, how does our graph here show that exact same thing?
When the y is, oh, that's true. When yeah, that's true. So if x is 200, y could be anything between 100 and 200.
Wait, which
Oh,
the
sorry.
200 seat ticket?
So it's going to be x is equal to 130.
200. So y could be, yeah.
X is going to be greater than 134
100.
or 133.
Yeah.
Yeah. So we're seeing, I can't see that exact number, that 134, which is why we had to do that math you guys just did. But we're seeing on that graph that same thing. If they sold 200 seat tickets, the number of lawn tickets needs to be 134 or greater in order to make that money goal that they have.
Yeah.
I gotta say, you all did excellent with this. Are you feeling good about inequalities, graphing, using them to solve problems like these?
Yeah.
How are you feeling?
I'm good.
Good. Is this a good lesson to end on?
I wish all lessons are like this.
Yeah. Well, you did great. Before you go, I can't remember if I mentioned it yesterday or not, but remember that tomorrow is the e-learning Friday. Remember, we have one each quarter. So tomorrow we will be posting something for you all. If you are one of the students who did not take STAR 360 at the beginning of this quarter, STAR 360 is going to be posted for you and emailed to you. If you are one of the students who did do it at the beginning of this quarter, you don't need to do it again. So you won't get an email from us. So that's one thing to look out for. And then the other thing, the school is asking all students tomorrow to do a survey. It is about writing. I don't know any more than that, but we'll post that in Google Classroom for you to do as well. So everyone will have the writing survey to work on tomorrow. And then STAR 360 will be posted if you did not already do it back in January. Any questions on those two things?
So what are we going to write on maths?
We're done.
Because I really
We're
don't
not-
understand writing in maths. Writing as in,
Oh, for the survey?
yeah.
It's just about writing in general. I don't think it's like it. Erica, if you have Erica as a teacher right now for English, she's posting the same thing. So it's not like specific to my class. It's a school survey just about writing in your classes.
Okay.
Denise, do you know any more?
I have a
Yeah,
question.
Miss Erica said, she said there's going to be writing, there's going to be